Okay, hello. This is Behruz Nazar, your instructor for Orgo 1. Trying to go over some section quickly. My last try, I really talked long and the YouTube wouldn't accept it. So I'm going to go a little bit faster. So textbook is again into sections. Each section has a skill builder, which is nice. Build the skill, practice it. We're going to use the skill builder, going to practice it, apply the skill, and more homework. So I'm trying to make it fast, and so I was going to be able to upload it to YouTube. So the first thing we're going to talk about is molecular representation. So that's really loose, in a nutshell, it's loose structure. If we have a structure which is very long, and I call it typewriter kind of structure. So we concentrate on different carbons. So the first carbon, we know it has two methyl groups. The second carbon, we know it has a methyl group. So again, this is the first two carbon. We realize that each carbon needs four bonds. So we need to have a double bond there, even though a double bond is not showing here. Then we know it's attached to an oxygen. We realize that the carbon, this carbon is attached to the oxygen. This carbon is attached to oxygen. Oxygen attached to a carbon, which is CH2, and that CH2 is attached to a CH, and that CH has a methyl group. These are called methyl group, one carbon unit. Now, what is CHO? We know that H has only one bond. We know H has only one bond. So this O has to be a double bonded to the carbon. So now the carbon has four bonds, oxygen has two bonds, and everybody's happy with the 8 octadroom. Now, if you look at the problem number 2.1c, which in the previous presentation I wrote it on a post-it note. So we have a CH3, CH2, parenthesis 3 times carbon OH. So this carbon has four bonds. One is O, and three of them are these groups, which we call ethyl groups. So if I look at that carbon, that carbon has three CH2, CH3, and one O. So the O has to have the H. So the O, if you look at my post-it note again, so this O has to have the H. The H can only have one bond. So this would be the structure where we're going to learn this as an alcohol. The next one I did quickly was Cl3CCO2H. So how are we going to do that? So let me post it over here. So we're looking at the carbon. So this carbon has 3 Cl. Then we look at the CO2H. So carbon has a O and a O, and this O has a H. So this O is okay, has two bonds. So move it over here. So this O is okay, it has a H and a carbon, two bonds. But this O we need to have one double bond. So it would have total of 8 electrons, and this carbon would have 8 electrons. So that's a carboxylic acid we're going to learn. Let's go to page number 2. So in page number 2, Dr. Kalani is asking us about different things in practicing Lewis's structure, partial condensed drug molecular uh, formula. So if I look at my ethyl acetoacetate, so we have a methyl group C double bond O, CH2, C double bond O, O, CH2, CH3. So if I want to make a zigzag structure, I count the number of carbons, 1, 2, this is not part of this carbon, 1, 2, 3, 4. Oxygen is part of the structure. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So carbon number 2, if I count it this way, as a C double bond O, CH2, C double bond O, O, CH2, CH3. The key is not showing the hydrogen on loose structure or zigzag structure. We know that this carbon has one bond to the carbon here. So there are 3 bonds left that we're not showing. So those 3 bonds are 3 hydrogen. 2 hydrogen here, no hydrogen here or here, 2 hydrogen here, and 3 hydrogen here. So again, we need to practice going from showing the hydrogen to a zigzag structure that the hydrogen attached to carbon are not shown. So let's go to slide number 3. So we have a little bit of rules for the zigzag structure. So we show it as a 120 degrees. Now if you have a C double bond O, we like to show it going up, not going down. If you have oxygen here as part of the structure, we show that. And then this time we like to show that all the electrons. Now the bond between the carbon here is 120. We can show it up, it's okay, but I like to follow the same pattern, 120 degrees. Again, if the O, nitrogen, boron have hydrogen, we need to show that. So we show that nitrogen here has 2 H's, oxygen here is 1 H, and boron has 1 H, and each of these oxygen have 1 H. So we H for boron, carbon, oxygen, we really need to show that. So that's different than carbon that we didn't show. Slide number 4, if I take my little post-it note out, again, that's what these chapters and many chapters Dr. Klein is telling us to do is we build this skill, we practice, we apply this skill, and we move on to more application, more practice. So he's asking us about the zigzag structure for this compound, and he explains it in the book. So I will go and look at that. So as part of the practice I did, I look at the CH3, 2 times CH, CH3, CH, CH3, CO2, CH2, CH2, CH3. So this was homework number 2.5. So what I did, I tried to draw it here. I said CH3, methyl group, remember, bonded to the carbon. So this carbon, which is a CH here, has 2 methyl group. Then we have a CH with a methyl group. We have another CH with a methyl group. Then we have CO2, CH2, CH2, CH3. What is a CO2? So CO2 is a carbon basically attached to 2 oxygen, right? 2 oxygen. This oxygen is attached to the CH2, CH2, CH3. So it has 2 double bonds, so it's okay. But this oxygen cannot be a single bond to carbon, it has to be double bond. So now carbon has 4 bonds, oxygen has 2 bonds. Now if I want to go make a zigzag structure from this, say I want to make a zigzag structure from this, let's put my little timer on, pause this. So make sure I have followed the time. So we have a carbon here, so we count 1, 2, 3, 4, 5. We count our oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3 carbons and an O. So I should 1, 2, 3 and an O. That O is attached to a carbon. That carbon has C double bond O. Then we have a carbon, carbon, carbon. Carbon, carbon. Each carbon has a methyl group, and the methyl group here is the N. So this would be the zigzag structure for this compound. We need to practice. On the next slide, slide number 5, he asks us to look at some of the functional groups. So we know the halide is a chlorine, alkene is a double bond, alkyne is a triple bond, alcohol is OH, ether is O, 2 carbons, thiols, sulfur H carbon, sulfur carbon carbon is sulfide, and ketones, C double bond O with a carbon carbon, C double bond O with the H and a carbon is aldehyde, and acid, esters, and amide. So we need to practice. We need to practice. Now I'm going to stop at this point and go back to the next series of slides. Thank you, and this would be the first portion.